Welcome to my video lecture series in Object-Oriented Programming. This is Professor Janice Raymond Tan from the College of Computing and Engineering.
For this video lecture, we will cover the topics about list of objects. Throughout this video, we will discuss the overview of list collection and the list collection operations. Data structure can be defined as the group of data elements which provides an efficient way of storing and organizing data in the computer so that it can be used efficiently. Some examples of data structures are arrays, linked lists, stack, queue, etc. Data structures are widely used in almost every aspect of computer science. An example, operating system, compiler design, artificial intelligence, graphics, and many more. Data structures are the main part of many computer science algorithms as they enable the programmers to handle the data in an efficient way. It plays a vital role in enhancing the performance of the software or a program as the main function of the software is to store and retrieve the user's data as fast as possible. Throughout this lesson, we will use a data structure to organize the objects that we will be handling in Java. Specifically, we will use the features of a Java list collection to implement some basic crude operations. Overview of list collection. List is a fundamental and widely used collection type in the Java collections framework. Basically, a list collection stores elements by insertion order, either at the end or at a specific position in the list. A list maintains indices of its elements so it allows adding, retrieving, modifying, removing elements by an integer index, which is a zero-based index. The first element is at 0 index, the second at 1 index, the third at 2 index, and so on. The following given figure illustrates a list that stores some string elements having apple at index 0, lemon at index 1, and so on. A list can store objects of any types. Primitive types are automatically converted to corresponding wrapper types. Example, integer numbers are converted to integer objects. It allows null and duplicate elements and orders them by their insertion order. Creating a new list collection of objects. It is a good practice to declare a list instance with a generic type parameter. For example, list student, wherein student is the class that you are creating instances inside a list to be stored. So list students is the name of your list collection is equals to new array list student. The given syntax above will allow us to make a list collection of our student objects from our student class that we will always use, or that we always use from the previous lessons. List is the class for us to declare and use a list collection object. Student inside the greater than and less than symbol is the class to be used to make object instances inside the list collection. List collection is not limited to creating a list of objects. We can also use the primitive data types, integer, double float, string, etc. to create lists. But throughout this video lecture, we will only work with creating list collections of our user-defined classes. Adding elements to a list collection. The method add object, which accepts an object, in our case, as a parameter, is used to add elements to the list. It requires to add elements of the same type or subtype as the type parameter declared by the list. Consider the given code. Person.java contains class fields such as first name and last name since it is believed that these properties are common to every person. We define non-parameterized and parameterized constructors, getters, and setters, and a getFullName method which returns the combined values of first name and last name as a string. Student class inherits the person class, and that is why it receives everything that is declared inside the person class. We use the extends keyword in order to implement inheritance. ID and course are the class fields of the student class. It also has a non-parameterized constructor, and a parameterized constructor that initializes not only the ID and course, but also the first name and last name as defined in its superclass, which is the person class, using the super keyword. The student class also has getters and setters. In main.java, notice that we imported two libraries, the array list and the list libraries. This is to avoid errors in using the list collection in our program. It is a requirement that you include the said libraries in every class file you will be writing as long as you will be using the list collection inside this class. The example code in main.java will not produce any output since we were not able to access the elements of the list students collection. Notice that we use the new keyword in creating student objects using the parameterized constructor of the student class as parameter of the add method. The only idea of the code is to create a list collection object named list students and add three student objects in the list collection. To make the code familiar to you, let us modify the previous code and likewise we can expect the same result. The modified code inside the main.java will do the same thing as the first example. The only difference is we first define three instances of the student class named stud1, stud2, and stud3, and then add those three student objects in the list students collection one after the other using the add method of the list collection. We can also simplify the modified code by just reusing a single temporary student object named stud to make it more efficient. You can use whatever possible way for adding new student objects in the list students collection. Choose what is more convenient for you and remember, all examples given in adding objects to the list students will all produce the same output. The given table shows what happens in our list students collection when adding or after adding the three student objects. Getting the size of the list collection. The size method of list interface in Java is used to get the number of elements in the list. That is, this method returns the count of elements present in this list container. For example, if you want to get and display how many student objects in the list students collection, the code will be just like as shown in the slide. System.out.println, open parenthesis, number of students, concatenated, the name of our list collection object, which is the students, that name of our method, which is size, followed by a pair of parentheses and a close parenthesis. So the output will be number of students is equals to 3, considering our previous example, which adds 3 student objects in our list students. Retrieving an element from list collection. The getIndex method, okay, or the get method, which accepts a valid index as a parameter, is used to retrieve an element from the list at a specified index. For example, the following code gets and displays the first name of the element at the second position in the list students collection. System.out.println list students.get. Inside that get method, we specified 1 as a valid index. So considering that 1, we are getting the second element in list students as shown in the table. The student with James Smith as the name. Then followed by the dot get first name. So get first name is our defined getter for the first name. Okay, so we use 1 as the index position of the second element from the list collection since index always begins with 0, followed by the getter of the first name class field, which is the get first name. Therefore, we will be able to display the first name of the student at the second position or index 1 and the output is James. Displaying all elements of the list collection. We can use a simple for loop in order to access and display all elements of the list collection. We need to use the size method to determine how many times the loop will iterate. For example, if we want to display the full names of all student objects stored in our list collection, we need to iterate through the elements of the list students and access each element for every iteration using the get method accepting an index followed by our get full name method defined in the person class. We can use the enhanced for loop to iterate through the elements in the list students collection as shown in the slide. Inside the for loop, we define a student object named stud that will represent each student in the list collection named list students to be used as a reference for every iteration. That is why in the body of the for loop, we printed the return value of the getFullName method using stud as the reference variable. Just like the previous example, we can print all the names of the students stored in list students. Replacing an element in a list collection. Use the set which accepts index as the first argument or first parameter, and the second parameter will be the element to put into place is used to replace the element at specified index by the specified element. For example, if you want to replace the student object at the second position, the code will be list students that set the first parameter after the open parenthesis is 1. That is the index position of the specific element within the list collection to be replaced, followed by a full student object because remember, in our list collection, it stores student objects. That is why we will also replace the current element at index position number 1 with a student object having Paul, Parker, 931, and BSBA as its details. So the contents of the list students after replacing the second element at index 1 is shown in R or in the given table. Okay. Modifying the fields of an element in the list collection. The get method will help us access the specific element of the list collection. After locating the element to modify, you can use the setters you defined in order to change the field value. For example, if you want to change the first name and last name of the student object at the second position, the code will be list students that get 1. Again, 1 is the index position of the second element to be modified. That set name or set first name because we will try to change the first name of the student at index number 1, which is will be replaced by Mary. Okay, then same what will happen with the last name. Okay, so list students that get 1 that set last name Hawkins. So previously, our student name is Paul Parker. Okay, so will be replaced with Mary Hawkins. Remember that you can only do this if you provided setters in your class fields, if you applied encapsulation in your class. So let us say, for example, we are not able to define the set first name method, or we forget to put the set first name method as defined in the person class. This will not be possible. Okay, so remember that if you want to modify a specific field and you applied encapsulation in that field, you should provide a setter method. Removing elements from a list collection. To remove an element from the list, use the remove method, which removes the element at a specified index. For example, if you want to remove the student object at the second position, the code will be like the given sample code. List students that remove index 1. Okay, so the contents of list students before removing the second element at index 1 is this one, the first table. After executing this code, list students that remove 1, our table or our list collection will be just like this one. Okay, so Mary Hawkins is now removed and Jesse Wesson is adjusted to the second element with index as number 1. Searching for an element in a list collection. By iterating through the elements of the list students collection, we can check every iteration the field for equality. For example, if you want to find and get the index position of the student object having Wesson as the last name, the code will be like the given code in the slide. The idea is, first, declare a variable named index position initialized as -1, since 0 above are the valid index values. -1 will be the value to signify that the last name to find within the list students does not exist. Iterate through the elements of the list students. Number 3, check if the last name field of every element is equal to Wesson for every iteration using the get method, followed by the getter for last name, and the equals method for comparing equality. Note that equals method is only applicable when comparing equality of strings. Use double equal sign if you will compare other data types. Number 4, if the condition for equality evaluates to true, store the value of the index as the value of the variable index position, which points to the position of the specific student object that matched the last name. Use the break statement to terminate the loop once found. Number 6, after the loop, check if the value of index position is still -1 after the iteration, which means the student with last name Wesson is not on the list. Otherwise, print the value of index position, which means it is found. Removing an element in the list collection by searching. We can remove an element in the list students collection by searching the element that matches a field value. This time, we will use the class field ID as the search key. Keep in mind that when working with list collection, you need to define each element with a unique key. In our case, we defined the class field ID. To make efficient programs using list collection, you need to have the control over assigning the value for class field ID by generating an auto-incremented value to make sure that every ID will be unique to each student object that will serve as their identity. In our case, we did not do auto-increment for the ID, but just to show the process of removing an element by searching, considering that still we assign unique IDs for every student object, we can consider the code given. For example, if we want to delete the student with 123 as the ID, the code will be like the sample code given. In summary, we could say that data structure can be defined as the group of data elements which provides an efficient way of storing and organizing data in the computer so that it can be used efficiently. List is a fundamental and widely used collection type in the Java collections framework. A list maintains indices of its elements, so it allows adding, retrieving, modifying, removing elements by an integer index. A list can store objects of any types. List collection applied to objects provide methods such as add, size, get, set, and remove. For this lesson's activity, create a program with the following requirements. Kindly read the given instructions. Post the link of the working program code using your account in codeva.io inside the post tab of week 10 channel of our MS Teams. That's it for now. Thank you for watching and hope you enjoyed this video. For inquiries, feel free to post your questions in our group chat. In our next video, we will discuss all about class association. Don't forget to visit the links in the references section for more information about this lesson. See you in the next video.